Hello, it's my real privilege to introduce another podcast with an old friend of mine, Shrirang Kulkarni, who's one of the real technical experts in the steel casting industry and has been in the industry for most of my career. So he's been around a long time. And one of his unique qualifications is he worked with a combined process to try and make steel castings using graphite molds. And graphite molds have been used for almost 50 years to make railroad wheels. So this podcast really is a conversation between Charlie, Dave, myself, and Shrirang about how do graphite molds work and what are the key advantages, disadvantages, limitations, all that on using graphite molds to make steel castings. So I hope you enjoy this podcast. It was fun to do. Thank you. So Shrirang, to begin with, of course, railroad wheels have been historically made for at least the last 40 or 50 years in graphite molds. And you basically had two different processes. You had the American steel foundry or Griffin wheel process where they use pressure pouring, and they actually would make a wheel and they just make it in a thick piece of graphite so they could machine it down and make the same size wheel. Then you had the ABC process, which used a traditional pouring method. And there you had a small wheel and you made it bigger and bigger until you couldn't make it anymore. So that's how you optimize the use of the graphite. And the use of the graphite was really attractive to get really fine microstructure on the running surface. And they had a really clever, both of them, way of using a sort of strainer core to connect the riser to the wheel so that if they timed everything just right, they could take the cope off of the drag without having to do any finish work.
Yeah.
And of course, any imperfection on the face surface after you machine it made that wheel scrap. So it was really challenging to make the quality you needed to be capable. Now, you were involved with ABC Rail with this.
Yeah. So you're absolutely right. And I know the process real well. So the first one is like ABEX, the one with Griffin wheel. That was patented by ABEX.
Oh, was it? Okay.
Yeah. And what they did, they made the entire graphite wheel entire railroad wheel with all graphite.
Okay.
Means everything was graphite except for the risers.
Okay.
They had more risers because, they couldn't just feed from the hub,
right?
Because all the other hot spots,
Sure.
So, but it was all graphite. Then ABC Rail came with their patent where they made the outside wheel complete. If you look at the blueprint I have sent, there are four kind of parts component you can call. The OD, the largest OD is called tread. Then you got the rim with the OD. The largest OD is the tread. And the one above that is the rim. And the middle plate, you can call that like web or a plate,
Sure.
And then the center hub, right?
Okay. Tread, rim, plate, hub.
When they made the railroad wheels, this is idler, the thickness, now this is the heaviest idler, so the rim is pretty thick, but on smaller idlers, the rim is pretty thin. So when they made the railroad wheels, the section thickness wasn't varying as much between the rim and the tread, because you know how railroad wheels are, it's pretty much uniform on the OD. So they were successfully making those. And for example, now you ride all that web used to be all graphite for the ABEX process. But what ABC did, they made the OD graphite, including the rim. And then they came inside and had a cavity for sand. And then the graphite came up and closed it close to the hub, but there was enough room for the sand everywhere. They blew it like with a core, big core machine.
Okay. Did you have a sand core on the cope and the drag for the web?
Yeah, it's not a core. It's like part of the mold. Yeah, but yeah, sand core. For the ABC process, it was like a core, but it was blown into the graphite.
Okay.
You know what I mean?
Interesting, because yeah, the railroad wheel, the drag was all graphite, and then the cope was sand.
For the ABEX, I didn't know their process because I didn't see that.
For the ABC rail processes, I remember they also had the drag was graphite. Sand.
No, drag and cope were both sand.
Okay.
The web part is sand.
Okay.
And it was blown like on the graphite, two separate graphite rounds, which you split in the middle. And then we had the strainer core, which fed the hub. Now, in the picture, you see I'm standing there. That's the drag half of the mold,
Sure.
And actually, I'll get into the idler in a minute. But basically, so the graphite wheels were all OD and the rim and everything was graphite except for the hub and the webs.
Okay.
So they were very successful with that. Now, what they had some capacity, so Caterpillar talked to them about making idlers in graphite process. And by the way, just like you said, there was not pressurized pour. It was poured right in the riser with a strainer core. Sure. And then the core would float up after it's filled, with the buoyancy in the riser. And it was sand riser. So Caterpillar talked with them about making this in graphite. So basically they followed the same wheel process. Graphite on the OD and the top of the rim, and then it followed the contour to give a sand, kind of like sand core. You can call it core, but really green sanded type mold, means. Okay. Yeah. So then it kind of followed the contour, but didn't touch the web, didn't touch the hub, and it had sand pretty much in between, and then the riser. So what was happening with the idlers, and it was boron steel.
Okay.
The idlers, the rim part, on the face of the rim, there were 30% of the castings were scrapped because of cracks.
Okay. So I wondered about that, Shrirang, because I remember talking to Earl Weber, your old friend and mine.
Yes.
He was, of course, Griffin Wheel as well as Steel Foundries.
Yes.
And he would tell me that they tried any number of times to make shape castings in graphite because it was so much less expensive and so higher in productivity. But every time they tried to make some shape part, they always end up cracking it, and they gave up on it.
And, the ABC people were not like foundrymen. They were like this railroad wheel is like 0.8% carbon.
Yep.
So it's a dead melt, and they don't know much about. So boron heats, they were having problem too because they were dead melt. They were not blowing enough.
Yeah, I'm not surprised that Caterpillar wanted boron, but members have always had a problem with boron because it tends to give you cracking.
Yeah, well, the cracks were not because of boron. It's because of the solidification stresses. So, but the boron steel, they didn't know how to make it because they were not steel maker. They were just melting 0.8% carbon steel, So Richmond at that point was going to close because we had just bought it from Cameron, and we had the Cameron work, but all the valves, But Cameron and the valve business was down. So we ended up splitting the valve work between Keokuk and Asalam. So Richmond was going to be like without any product. So Vaughn McCary sent me to ABC Rail in Calera and said, well, look at this idler product. and maybe we can start that. And they had another foundry that was making manganese steel, like rail bounds and crossings in Indiana. So
right. You had the plant in Anderson, Indiana,
Anderson, yes.
They,
Calera.
I'm trying to remember the guy who ran it. He knew the manganese steel stuff really well.
Yeah.
And he's still kicking around a little bit. And then they had the plant down in Calera where they used the graphite molding.
Yeah. But Calera made like 500 tons of wheels every day. You know? That was very high production.
It was a bottle cap factory.
Yeah. And they couldn't weld, so you have to scrap. So actually, Juan had sent me to kind of figure out, use the multivariate analysis and DOE, and I was into that, finding the red X for their inclusion problem too, which we did find some solutions. Like the first pour was always bad, and then we figured out how to make that first pour better. But anyway, that's another story. So I saw the idlers and I said, well, you are covering the rim completely, OD, face, and OD and face, not inside, but OD and face, yes, with graphite, and then you're blowing the core, of course, with the sand. But the cooling rates are extremely high on the rim compared to the tread. And that's why these are cracking. So I said, what if we put sand on the face, which becomes the bottom of the drag and top of the coat? You know what I mean?
Sure.
That will solve the problem. So I cut out their graphite, one whole $5,000 worth, I cut that up, the blowing part and the top part, and just made a round with the tread and the rim. So what you see in my picture there is the graphite round. And the idea of that is shaped just like the OD of the casting. You know what I mean? But in bottom was open like sand. Bottom or top face, yeah. So I cut that out and took it to Richmond. It was a D8, they make from D7 to D11.
Yep.
Terry Myers, I couldn't remember the other day the name, but Terry Myers was involved.
Oh, sure, Terry.
Yeah, the other day I was talking to Dave and I couldn't remember, yeah. But Terry Myers was kind of working with foundries. So I made that D8, which was like a D7 was the smallest, D8. They had some extra graphite. So I made that and poured boron steel, one heat, and 0 cracks.
Wow.
Yeah. So Vaughn and Joe Sayre wanted me to write a patent on that, and we did, but I don't know. It was so close to the ABC process,
Yep.
We didn't get it, but it was a foundryman's idea, because these guys were not foundrymen, and as soon as I saw that, I knew the cooling rates and sand versus graphite, and no cracks. So then now Terry was convinced. I brought him there, showed him the wheels, and he said, well, now you got to sell it to Caterpillar. And the whole problem was, it was like $500,000 worth of graphites, with all the sizes.
Wow. Well, and historically, the use of the graphite molds, especially at ABC Rail, that the price of their
it's like $5,000 around. $5,000 around.
Yeah, they originally, when they first moved the idlers to the ABC Rail plant, they cut the sand casting price almost in half by going to the graphite high volume production. It was really much cheaper, which was one of the reasons that Caterpillar was so interested in the process. But you're saying the tooling was really expensive.
Well, what it is, because if you're making so many rounds and so many sizes,
Yep.
D7, 8, 9, 10, 11, 5 sizes. Each one had like, you know, 20 graphite rounds. And then, like you said, we machined from the large side, from the small side to the large side, exactly like you said.
Right.
That's what we did. But basically, there were 2 graphite rounds put together and sand in between and a riser in the middle. Only thing was, the rim was also chilled with graphite, rim face. And that's what I changed. So I had to cut out, and the whole top where they blew, you know, sand, it was all graphite cover. And there was a center diameter where they blew the core, where they blew the sand on the graphite. So I had to cut out the whole top surface of it, top plate of graphite, you know, where they used to blow, like a blow core, like a I-Secure core box type thing, you know, but huge core machines. So Terry said, well, you know, this looks like it works, but how do we sell it to Caterpillar? Because now all this graphites we have to machine, and then you can't go back, you know?
Yeah.
My idea was to make it like an air set mold.
Yep.
Being graphite round is the wooden box, you know?
Yep.
Center. So you just put it under the mixer, fill it up, strike it off, you know?
Yeah. That sounds like a clever idea. So you were basically looking at using the graphite as a shaped chill.
All the outside to chill, everything outside, you know?
I was really interested because I looked about graphite molding, and graphite molding is actually pretty commonly used. Let me move your.
Yeah, I see.
Is really pretty commonly used for precious metals. So if you make jewelry, you can do that. And there's a couple of videos about how to make the graphite molds. And this is where I went and looked and found all these molds. So it's pretty interesting. And I knew that people had used graphite as a chill. And so you were basically looking at using graphite as a chill for the OD of the whole component.
Yeah. And I was just following the ABC principle. They also used the whole OD, except they were putting the rim face in graphite too, which was causing cracks.
Yeah.
You know what I mean?
If you did that, did they ever test it to see if you got better life because of the rapid solidification?
Better life at Caterpillar, that's what they believed.
Okay.
You know? Now let me tell you the whole story. So what happened now? How do we sell it? So at that time, Magma had just come up with the stress module, you know?
Okay.
And I was in Chicago, our head office there, you know, I was the corporate technical guy.
Right.
So we had Magma there. So I ran stress with the graphite on top and with the sand on the top of the rim. And it showed quite a bit difference in the stress level, solidification stresses, major difference. So, you know, I had to go in a Caterpillar meeting. There were like 15 PhDs sitting there, you know?
Yeah.
And I couldn't show them the pictures with cracks and without cracks. I had to show something like this stress analysis. So I showed the stress analysis and they bought it.
Wow.
Yeah. And I machined all the graphites and started making D7 to D11, 500 tons a month of idler. So we re-engineered basically Richmond Foundry. And on the large line, on the kind of like a large molding line, we made the railroad bounds, you know? So that was manganese steel. So we had an olivine sand, 2 sand systems separate and Pepset separate, graphite. So basically, you know, I made it like a simple graphite round mold. Instead of like a wooden box we put, it's like graphite.
Okay.
Which makes the and just filled it under the mixer and then just like normal, drew the pattern out and closed the two graphites. And then there was a riser with a strainer core. So the plate or the web
Right.
being in the sand, it fed from the web stayed hot, and the graphite chilled the thread.
Right, right.
That hot spot, thread and the junction of rib also, but not the face. And
Sure.
there were no cracks. So we converted D8 and D7, one by one. And our man hours per ton were like 20.
Wow.
And the procedure was for each graphite, there were so many minutes, and you pull the riser up with the coke.
Right.
So the riser is still in the mushy state.
Right.
So all we did was we trepanned the center hub,
Sure.
We had a trepanning machine.
Right here.
Right there. And then a machine, the ODs, and that's it. So,
wow.
There was no cleaning, period. Because the riser, the contact was removed by the trepanning.
Right.
So, graphite spec was written like that. It has to be made in graphite for the finer grain structure, and life is great and all that. So we were like, oh, it's never going to change, We got it forever now, this 500-ton business. So then what happened? D8 was the model that was made in Brazil, the whole tractor, they manufactured in Brazil. And so Maxion is the foundry in Brazil,
Yeah.
They used to make these in sand casting.
Sure.
All sand, like a conventional sand. And the D8, it was gone on those D8s that were used in Brazil.
Right.
And I guess they were shipping here too. So somebody in purchasing got an idea like, okay, well, looks like the sand casting works in Brazil. Why not start buying D8s from Brazil?
Wow.
So the first step they did was started getting the D8s from Maxion. So we were making very few D8s. I mean, they still continue, but all the other models we were making. Then slowly, with their corporate management, they said, well, it's not really that big a deal of grain fineness where the application is, and it doesn't matter, which we were surprised. So they gave me a 6-month warning. I mean, we had a meeting and we were going to move all the idlers in sand. So I kept making extra idlers for like 6 months. And with Terry Meyer's help, actually Terry said, well, you got to keep Richmond open, because they were really mining was going crazy at that time.
Sure.
And Atchison and Harrison were not able to keep up.
Sure.
So they said, well, Shrirang knows pepsit molding and normal Caterpillar castings. He's worked with CAT castings before. Why don't we move some of the Atchison and Harrison patterns to Richmond? So while they're making idler and phasing that out, they can prototype all these other, like I made like 200 patterns, and sampled through in 6 months. And while we were making idlers on the idler line, on the other line, we started making the regular production and then phased out the idlers. So that was second time I had to re-engineer. So there were 2 times we were going to close, but we re-engineered and kept going for another 5-6 years. But then, of course, CAT business went down and Indian company bought us. So I ended up moving all the CAT work to India. So that's the whole story. But the interesting part is the idlers and the cracks,
Yep. No, that's a very interesting story. I really enjoyed it.
I have a question on that. So you sort of talked about this with the stress analysis and the cracks, but with that finer grain structure, I think, did you ever see any data from Caterpillar on fatigue for that? Did it better in life?
They believed it, so they never showed any data, because by the time I got into making idlers, they've been made with graphite for several years at Calera, and everybody believed that's the only way. So we felt, Raymond, we were selling it for $1 a pound.
Okay.
Idler at that time. It was that cheap, $2,000 a ton. It was that cheap.
At Calera, if I remember the prices, and this is like 30 years ago, so these prices don't mean anything anymore.
Yeah.
They were basically selling they could make the railroad wheels for about $700. So it was like 35 cents a pound.
40 cents or something like that.
Yeah.
So idler being steel.
The idler was like 60 to 70 cents a pound.
Yeah. So we had to get a price increase to $1 a pound.
Wow.
And we stayed like that. So I was never showed any data. They just based it on the D8. It goes in the dirt, whatever.
Did you measure the depth at all ever, Shrirang?
Huh?
How deep did it go?
How deep did you get the fine microstructure, and did they ever do
we never looked at,
Okay.
But it was all graphite on the OD.
Sure.
So that really,
you got to be careful. You didn't machine any of that surface off.
Yeah, we did machine. We machined the ODs.
Okay.
Yeah, just like a railroad wheel. Yeah.
Okay.
Yeah.
So obviously you didn't machine away all the how much?
No, it's much deeper than that. Yeah.
Okay. How much machine stack? What were you machining off?
The OD.
A quarter of an inch?
No, not even that.
Okay.
1/8 inch.
Okay.
Because it was clean, There was nothing. Yeah.
That's really cool, Shrirang. I'm glad you were able to watch the podcast. Certainly willing to follow up with Shrirang on any questions you might have, or have another podcast if there's other topics you'd like to do. Also, always want to invite you to send in suggestions for guests for the podcast, as well as topics that we could discuss. Really look forward to doing that in the future, and hope that you enjoyed this podcast as much as it was fun to do. Thank you. Goodbye.